So I'm not sure about which one you're questioning about, the isosceles triangle one or the cones. I suspect it's the cones. Let's start with the cones, and you can ignore the rest of the video if you got the other one. Cones is actually easy. Let's talk about ratios. Ratios just means for every distance of that, distance of that. For instance, if I'm 6 feet tall and you're, let's say, 5 feet tall, okay? Our ratio, our ratio of height to height, using me as the first one, is 6 to 5. That means for every 1.2, is that right? 1.3, 1 foot 3 inches, I go up, you go up a foot. And by the time we reach the 6 feet, you've reached the 5 feet. And it just means for every 6 of my feet, you have 5 of your feet. Looking at this cone thing, what they say is, they start off with the radius, and they say the radius have a ratio. And they've actually even drawn it for us. You don't even have to understand the cone formula. The ratio, they say, is, well, for its 5 foot of radius, the other one has 4 feet. And the reason they say ratio is because they're saying for it could be for every 50 feet, it has 40 feet. It just means that if you were to take his ratio for every 5, we get every 4 of his. And if we were to figure out his based on this person's based on this person's, we would take his, divide it by 5, and multiply it by 4. Because we're dividing by his ratio and multiplying it by what yours is to get your actual thing. Doesn't matter though, they give us 5 to 4, that's all we need. So it just means if he's 5 feet, 5 meters, whatever, radius, this guy over here is only 4 feet. Then they give us their height. He says for every 2 feet of height this guy has 3 feet. That's easy, that's all we need to know. They say if those are their ratios of their heights and those are their ratios of their radius, what are their volume ratios? What are their volume ratios? Now, you could work out the whole volume for this and then work out the whole volume for that. And it'll take you longer. But let's look at what the first, let's call him 1 and him 2. Okay? If I work out the volume of this one, I'm going to take the formula and I'm going to say, well, 1/3 pi. Those are both constants, 1/3 and pi. And then his radius, which is, in this case, 5, and radius squared, so I always have to square first, times his height of 2. And then if I look at his number 2's thing, he gets multiplied by 1/3 pi, times his radius squared, which is 4 squared, times his height, which is 3. Well, if I'm going to look at their ratio, and when you look at your ratio, you take this person's height and this person's radius and that person's radius to figure it out. For instance, if we go to my height to your height, 6'5", to figure out our ratio, we take my height divided by your height. So my ratio, height to yours, is 6 to 5. And we write it like that, 6 to 5. If yours was, let's say, a divisible number, like 10, we wouldn't say it's 6 to 10. We would say, oh, they can both be divided by 2. We could say the ratio is actually 3 to 5. Because you don't want to keep trying to get a simple ratios number. Well, here if we look at them, they're both multiplied by 1/3. We don't even have to consider the 1/3. They're both multiplied by pi. We don't even have to consider the pi. We just have to take this thing and divide it by this thing to figure out what the ratio is. You can keep the other things in there if you want, but if you look, when we divide them, well, this divides itself, and I told you a number divided by itself is just itself. And this divides by itself, a number by itself is just the self. And we're just left with this divided by that. Same with this side. So let's look at that. Let me get rid of the mess. And we're going to go back to the formula. And instead of writing the full formula, we're going to skip the 1/3, we're going to skip the pi. And we're just going to use what we need. So what's the ratio of this? This one, so we got a 5. So it's 5 squared times the height. What is that? Well, that's 25 times 2, which is 50. And he's the person we're talking about, so we start with his 50. What's the other person's? Well, his ratio squared is 4 squared times his height, 3. 4 squared is 16 times 3 is 48. Now to find their ratios, we simply take 50 and divide it by 48, just as we would take my height and divide it by your height. Well, 50 by 48, as I said, is fine. but we can look right away and see that this can be divided by 2 and this is divided by 2, and we want it as simple as possible. So the ratios are 25 to 24. You can write it like that. You can also write it as 25, 2 dots, to 24, which simply means for every 25 units of volume, because remember we converted it to a volume, this person's volume goes up for 24. So if this person's goes up 25, this person's goes up 24. And it's simply a way of finding relationships in case you need to know if I increase that, something happens there. So this is their ratio. That's all they're asking. Let's say you're asking me the other question, and that's fine. So let's say you want to know the isosceles one is just as easy. So if you remember, an isosceles triangle has 2 sides the same side. And I don't think you're asking this. You can go ahead and stop the video if that's not what you're asking, but now it's this one. In this one, they're going to give us the length of the 2 sides, and they're just going to give it in an equation. So normally an isosceles triangle would look like this, and this side here would be the same as this side, and that's what that symbol means. In this case, they're telling us, well, this side is 9x plus 3, and they're also telling us the identical side is the same. What they're not telling us is called this mystery length. Let's call it L, this mystery length. But they are telling us the whole perimeter. The whole perimeter is if I were to walk all the way around the triangle, what is the total way around the triangle? Well, they tell us right there, it's 30x plus 10. That's the whole perimeter around it. Well, how do you find perimeter? Well, that's easy. You simply add length plus length plus length to find perimeter. They've given us 2 lengths. They've told us 9x plus 3 is 1 length. And we're going to add it to the next length. Well, they've given it to us, 2. And we would add it to the last length. Oh, we don't have the last length. But all of that added up should equal to 30x plus 10, the total perimeter. So now we simply isolate L. Now here you might say, oh, do I divide? No, everything's being added. We could just remove these brackets. And if anything, you can see there's 2 common apples here. So we got 18x. And there's 2 common oranges here. So we got plus 6. Plus L is equal to 3x plus 10. Well, we don't want the plus 6 on this side, so we're going to subtract it. And we're going to subtract it on this side. So these just nullify themselves out into 0 because we're subtracting, not dividing. And we're left with 18x plus L is equal to 30x. And what's 10 minus 6? It's plus 4. So now we want to get rid of this 18x, which is being added to the length. So we simply subtract it. If we subtract on that side, we subtract on this side. And finally, we're left with length is equal to 12x, which is 30x minus 18, plus 4. We cannot get it simpler than that. We don't know x. If they were to ever tell us x, we can figure out the length of every side in numbers. So we figured out that the length here is 12x plus 4. Not too hard. Neither was that stupid cone one. You just got to, if you wanted to work with the formulas, you could go ahead and figure it out. So there's that one.